Let's look at a quadratic formula where there's some additional canceling after we simplify the radical. Solve 5x squared minus 4x minus 2 equals 0. A is 5, B is minus 4, and C is negative 2. After I write the quadratic formula and insert the values with parentheses to protect myself from losing the signs, I begin to simplify. The opposite of negative 4 is 4. 2 times 5 is 10. And the number under the square root will be 16. And 4 times 5 times 2, 40. 16 and 40, I'm going to add them together because I have negative 4 times positive 5 times negative 2 to make positive 40. Now I have 4 plus or minus the square root of 56 over 10. There's a perfect square inside 56. I think of 56 as 4 times 14, so the square root of 56 is the square root of 4 times the square root of 14. I know the square root of 4 is 2, and the square root of 14 I don't know, so I leave it as that. So I reach 4 plus or minus 2 root 14 over 10. I could stop here, but I would be leaving something unsimplified. I notice that there's a factor of 2 in the bottom. 10 is 2 times 5. There's also a factor of 2 in the top. There's two terms in the top, and they both have a 2. So I need to factor that out. 4 plus or minus 2 root 14 is really 2 times 2 plus or minus root 14. 10 is 2 times 5, and I can cancel these 2's and get 2 plus or minus root 14 over 5. I don't cancel until I've factored the term out of the numerator. I don't cancel when I see 4 over 10 because that would only be canceling part of the numerator. I have to see the factor in both pieces in the numerator, the 2. I have to factor it out, and I have to cancel it with the factor in the denominator.